All right, y'all. So 2.3 gets a little bit more into finding domain and range. All right, y'all let one in real quick. All right, so they're going to start out giving us pictures of graphs and they want us to find information from. So it says for the graph, determine the following. All right, y'all keep letting people in real quick. All right, so first we're going to draw this graph, and this one has points plotted on it. So y'all, this is all right. Another one. All right, y'all. So let me see where they got these points at. Over here at -6, they're at 5. At -5, they're at 4. -3, 3. I mean -4, 3. Uh, -3, we're at 2. And then it sort of goes back uphill. All right, -2, 3, -1, 4, and then at 0, 5. So it's just a little V-shaped points here. All right, we're filling up tonight with people, ain't we? Okay, so y'all, for A, they want me to find f of -6. Now, you got to remember what we said the other day about the f of x. Remember, we said f of x equals y. So if they're giving me an x value here, they want me to find the y value. So for this question here, they want to know what y value corresponds to the x value of -6. So since they gave me a -6 for the x there, They want me to find f of -6, which is what y value corresponds to that x value. So y'all, here's -6 on my x-axis. So I'm just going to go straight up, find the dot that corresponded with -6, and I'm going to look straight across and see what that y value is. So y'all look here at -6, I got a y value of 5. Anything on this horizontal line going across would have a y value of 5. So y'all, that would be our first answer, 5. So for part B, they want the domain. Now, MATLAB will give you these little curvy parentheses, and they want us to put in the domain. We all remember the domain is the set of all x values for this graph. So I would go to each one of these points and see what their x values are. So the first point, you come straight down, has an x value of -6. The second point, if I come straight down, has an x value of -5. The third point, coming straight down, has an x value of -4. And y'all continuing on, the next point has an x value of -3. The fifth point here, coming straight down, has an x value of -2. This point I come straight down has an x value of -1. And then finally, this last point comes straight down, has the x value of 0. All right, y'all, let me let one in real quick. Okay, so just remember, when they want the domain, they just want all the x values that are represented by these points, okay? So let's see what they want on part C. They want any x values for which f of x equals 3. So now they're giving me the y value of 3. They want to find what x values have a y value of 3. So we need to find 3 on our y-axis, which is right here. Now remember, since this y value of 3 is right here, anything going across that horizontal line has a y value of 3. So that'll give us x equals. Now MATLAB will give you the x equals. You're just putting in the numbers. So this point right here had a y value of 3. So coming straight down, that x value was a -4. And then this point right here to the right of the V, it has a y value of 3. So coming straight down, that has an x value of -2. So these problems are sort of opposite of each other. This one gave me the x. I found the y value. Down here, they're giving me the y value and we're finding the x values. Y'all just remember, anything that crosses that horizontal line at 3 would have that value, okay? All right, Sylvester, I didn't catch you in time, but good job. That in part D here. For D, they want the range. So remember, if the domain was the x's, the range is going to be the y values. So I'm going to start at the smallest y value and go up. So right here, this B point is my smallest y value, and that has a y value of 2. These 2 points we just got finished with a while ago, both of these points have a y value of 3. But since they both have a y value of 3, we don't have to put the duplicates in there, okay? We just got to list that number once. All right, the next y values are coming through these points, and they have a y value of 4. And y'all, finally, these 2 points, if you go across, they both have a y value of 5. So y'all, all they're doing here is getting you more squared away with that domain and range, okay? All right, y'all, so any questions on that one? Because we'll do another one with lines. All right, y'all, so this next one will be a little tricky to draw because it's going to be a line here. But we'll do the same thing. It says use the graph to find the following. All right, y'all, so let's make our graph real quick here. All right, so I'm gonna go out about 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 on this one, it looks like. Okay, y'all, it's touching right here at the 6 on the x-axis. And then let me see, it goes up here, going up 1 there, and 1 there. Then it's just straight lines, okay? It looks like a V-shaped graph heading off to the right. And then this left side heading off to the left. And it's pretty much got the same type questions on the last one. Only difference is they're using lines here versus the points, okay? So first of all, they want us to find f of 2. So we're going to go to the x-axis at 2 right here. And we're going to go straight up. So if mine was drawn a little bit better here, it should be at this 3 here. So my lines are a little off. But I'm going to say that had a y value of 3. MATLAB's graphs will be a little more readable than mine, okay? So remember, they gave me the x value. I found the y value that corresponded to that x value, okay? So now how about the domain? Well, the domain is the x's, but y'all look at this. These x's go to the right forever. they're headed off towards what we call positive infinity. The x is to the left because this graph is going forever to the left. So this side's headed towards negative infinity. So when your domain goes in both directions, we say that that domain is all real numbers. Okay, and math lab will have a choice that says all real numbers, okay? Are y'all with me on that? Because these x's are going to the right and the left on it, okay? All right, for C, any x values for which f of x equals 1. So that'll be x equals. So y'all, what x values have a y value of 1 is what they're asking on that. So here's 1 on the y-axis. So if I run across with a horizontal line, looks like we got 2 points. What y'all got up there? Levester, Madeline, 5 and 7, perfect. Right, this point had an x value of 5. This point had an x value of 7. And then the range. Now notice this. The domain was all real numbers because it went both directions. But my range, it's not going to be all real numbers because the range is starting at 0 and going up. It does not come down here in these negative y values. Okay? So it's only going up and it's starting at the y value of 0. So for this one, we would say that our range is the y such that y is greater than or equal to 0. See, since it's touching that x-axis right here, that's 0 for the y. And they're going up toward the positive values, okay? So we just say that it is greater than or equal to 0 on that one. So y'all, that's the trick when you got graphs, okay? Whether it's plotted points or a graphed line, okay? All right, y'all, but we're here to do function stuff. So we're going to find the domain of a function. So finding the domain of a function. Now, here's the thing you got to realize about a domain. All the x values that are in my domain have to give me a real number when I plug them into the function, okay? So the x values must result in a real number when put into the function. So Nicole, this is 2.3, okay? All righty. At this point in life, there's only one thing I'm worried about that will not give me a real number. Remember, real numbers can be positive numbers, negative numbers. Real numbers can be fractions. Real numbers can be decimals. Okay? But the only thing we're worried about right now, so the only functions we are concerned with are functions that contain a variable in the denominator of a fraction. So why is that? Let's recall. Any number, I don't care what number you put in for that A, but any number divided by 0 equals what? Y'all remember what we called those? Undefined. Good job, Taylor. Which means we don't get a number when we divide by 0. That thing's undefined. You cannot do that. So that means if I got a fraction in my function, any numbers that make that denominator equal 0, we got to kick them out. So any functions in which an x value creates a 0 in the denominator, must be excluded from the domain. Okay. So what I got to do, y'all, if I do have a fraction there, I'm going to take the bottom of the fraction, set it equal to 0, and see what numbers I get for my solutions. Those solutions are going to be excluded from my domain, okay? Because y'all, we can't plot X is 5 and Y was undefined, okay? So just remember, we're going to exclude numbers that make the denominator of a fraction equal 0. Now, whoops, let me write one more thing. If the function does not contain a fraction with a variable in the denominator, then the domain is all real numbers. So, like I said, if I don't have a fraction with that variable sitting in the denominator, then the domain of any of those functions will be all real numbers. Now, if I do have a fraction, I'm going to see what number makes the denominator equal 0, and I'm going to kick it out of my domain. Okay? So, y'all, here we go. We're going to find the domain of the function. And y'all, let's see, there's like 1, 2, 3, 4, 5, about 6 of these, but they're pretty quick if you get the idea of what's happening here, okay? And these will start around number 3 here. My first one, they're giving me f of x equals 10 over x plus 15. Well, y'all look at that. They gave me a fraction to start out with on this one. But since I got a variable in this denominator, there is at least one number that's going to make that equal 0 down there. And that number will get kicked out, okay? Now, it's easy to tell on this and what that number probably is, but technically what you would do, you would set the denominator only, set that denominator equal to 0. We don't care about the top. The top can be 0, the top can be any number we want. The bottom's what we're concerned with. And y'all, to solve this, I'm just going to subtract 15 from both sides. So then I get x is a negative 15. So y'all look at this. If I put a negative 15 in for the x, negative 15 plus 15 is 0. 10 divided by 0 makes that undefined. So my domain will be x such that, so remember this bar means such that x is a real number and x cannot equal negative 15. So y'all, this is telling me any real number works other than negative 15. I can put a negative 14 here. I can put a positive 14 here. I can put a 0 plus 15. I can put decimals here, fractions. It don't matter what I put here. The only number that I cannot put there is that negative 15, because that's the only number that'll make that undefined, okay? Y'all with me on those? All righty, y'all. So let's try this next one then. So this would be like our number 4. So 4, doing the same thing. We want to find the domain. They're giving me p of x equals 2x minus 10. And y'all, I'll tell you, in the future, there's only 2 types of numbers that won't give that we're looking for from a domain, and that's the undefined. And later in life, the other numbers are going to be imaginary. But we won't hit them until second test material, third test material, around there. All right, here's your function. What's my domain? All right, y'all. So remember what we say right here. If a function does not contain a fraction, with a variable in the denominator, then the domain is all real numbers. Well, I don't see a fraction there, do y'all? Nope, so this will be x such that x is a real number. So any real number works. I don't have to exclude anything. I can put a fraction here, a decimal, negative numbers, positive numbers. Any number you give me, I can multiply by 2 and then subtract by 10. That's going to give me a real number that I can graph for my y values, okay? Oh, I'm going to throw a curveball at you right here. G of x. So here comes your curveball. This equals a x squared plus 7. So, what's the domain? So Catherine said all real numbers, question mark. Well, guess what? It is definitely all real numbers. I don't see no fractions. So whatever number you give me, I can square it and then add 7 to it, okay? So we got no restrictions. So that'll be x such that x is a real number. Now, MathLab will have all this written out for you, so you don't have to write them out. You just pick A, B, C, D on these ones, okay? All righty. How about a h of x equals 4 over 4 minus 3x? Well, this one can't be all real numbers because I got a fraction with a variable in the denominator. So we'll set that equal to 0 and see what value to kick out for that x, okay? And remember, we're only concerned with the denominator here. So set 4 minus 3x equal to 0. We'll solve that. And then that x value is going to get kicked out of my domain. And y'all, that's why we're actually setting them equal to 0. Because that's what we cannot have here, okay? So y'all, what y'all doing? Subtracting 4 on that first? Get that negative 3x by itself. So those 4s will cancel. And I'll have that negative 3x equals that negative 4. Then I'm going to make that a 1x by dividing both sides by negative 3. So we'll have our negative 3x divided by negative 3 will equal negative 4 divided by negative 3. So these negative 3 divided by negative 3 makes that a 1x now. Oh, and y'all look at that. Negative divided by negative is going to make that a positive 4/3. So for this one, my domain would be every real number other than 4/3. So x such that x is a real number and x cannot equal 4/3. Okay, so if you notice, the only ones I've had to do any work for was the fractions, okay? So y'all good on that one? Any questions? All right, I'm not seeing anything, so let's try number 7. P of x equals the absolute value of x minus 2. So hell, now they're throwing the absolute value at you. So the question is, what's the domain? Well, the best that was quick, but all real numbers, right? There's not a fraction here. Any number you put in there for the x, I can take the absolute value of it and subtract 2. That'll give me a real number in the long run. So good job. X such that x is a real number. And y'all, I want y'all to see that any function is all real numbers unless you got a fraction, okay? So let's see if that holds true for this one. P of x equals, woo, check this one out. X to the third minus 5. All right, how about that domain? All right, so Madeline, well, y'all getting them quick now. Good job, y'all. Once again, any number you give me, I can cube it and then subtract 5. So for once again, this is x such that x is a real number. And we're done. Y'all, that was 2.3. You got a couple graphs. One will be plotted points. One will be lines. And then you got about 6 questions doing the domain. And the only ones I had to do any work were those fractions, okay? All right, also, any questions over that before I do the support? All right, so y'all are saying no, thumbs up, good job. All righty, so. All right, so the support we're about to do is going to get us ready for doing our operations on these functions Thursday, okay? I'm gonna let y'all catch up on them notes real quick and then we'll start our support. All righty. All right, so this is 2.4 support, and y'all, let's see, it's 1, 2, 3, 5 problems, just getting you ready for like terms, a little bit of distributive property, and a little bit of foiling. So this first one, they're giving me 8d minus 3 minus parentheses 2 minus 5d. So this one is really wanting to show you what you do with these parentheses. Now, these parentheses are following that subtraction right there. Now, you got to realize this. We're not just going to subtract 2. We're going to subtract that negative 5d also. You got to distribute subtraction through those parentheses to everything inside those parentheses, okay? So I'm going to rewrite it without the parentheses. So I didn't do nothing to the 8d, I'm bringing that down. We're not doing nothing to the minus 3. We're bringing that down. But now we're going to distribute our subtraction. So that negative times that positive 2 is going to make that a negative 2. And what's going to happen with this negative being distributed times that negative 5? So good job. That's going to be a positive 5D. So y'all, here's the thing about subtraction. It'll change the signs of everything in the parentheses. That 2 was positive, became negative. That negative 5D was negative, it became positive. All right, y'all. So now, can I go further with this one? Oh, Alicia, that's good job. You're shaking your head because I got 2 sets of like terms. I got an 8D being added to a positive 5D. Now, y'all, here's another thing you got to realize. When you add or subtract like terms, you cannot change the variable. So if you add 8D to 5D, you got 13D. A big mistake people do. So right, see if you got it up there perfect. What hurts a lot of people is when they add D's and D's, they make them into D squareds and stuff. But good job. You cannot change variables when you're adding. And y'all, that negative 3 and negative 2 gave us a negative 5. So good job. You had it perfect, lines up there. Okay. Good job. Now, this next one is strictly a distributed property. They got negative 4 times parentheses 7A plus 2B. So y'all, here's the thing about this one. Similar to the one we just did, but this one was just a subtraction by itself. So you almost treat that one like a negative 1. But y'all, you got a negative 4 in front of these parentheses. So you got to distribute the whole negative 4 times both of them. Not just the 4, it's got to be the negative 4 going through here. So y'all, here we go. Let me see what y'all would get after y'all distribute that negative 4. So y'all just chat me what y'all get on that. So let's see, negative 28A minus 8B, perfect. So negative 4 times 7A gave me negative 28A like y'all got. And then negative 4 times 2B gave us a negative 8B. And Alicia, also, whenever you get a plus negative like that, you can just put a minus and be good with that, okay? All right, so y'all got the idea about the distributed property and the like terms, okay? So what about this? 8C squared times 4C. Are you all right, girl? All right, so here's the thing. Recall this property we learned in the past about variables. X to the A times X to the B equals X to the A plus B. When you multiply variables, you're going to add the exponents. Okay? Now, the 4C, that C didn't have an exponent, so you automatically got to treat it like a 1 there, okay? Okay, Taylor, I was about to say, Taylor, you had the C3, right? But I was looking at that 8, trying to figure out what you did to it, but you got it fixed. So 8 times 4 was 32. And the c squared times the c, I'm just going to add 2 plus 1, and that's going to give me a c to the third. Okay? So that I'm just going back to recalling y'all on multiplying variables, add the exponents, okay? All right, so the next thing we needed to practice on before we hit 2.4. R minus F times R minus F. So this is a lot of multiplying, and they even gave us a, I guess, formula you can use on this one. You can use the FOIL on this one. Now, there's two things this lets me know. This lets me know I better multiply 4 times, and then it sort of gives you a pattern to follow. But y'all, really, I'll tell you what, it's doing this distributed property like this twice. First, you distribute the R over here, then you're going to distribute that negative F. So here's where to get the FOIL from. The first terms of each parentheses. The first ones from each parentheses. That's the R times the R. Well, guess what? R times R is R squared. Now remember, they don't have exponents on none of these variables. So all these exponents would basically be a 1 for everybody, okay? So all these have an exponent of 1. Now, the O is the outermost terms. So look here. The R got distributed times the R. Now the R is getting distributed times the F. So R times a negative F is going to give me a negative FR. Now I'm just keeping my variables in alphabetical order, okay? Oh, Aaliyah, you're so close, but let me get another step or two and I'm going to figure out what you did there, okay? All righty, y'all, that's the F and the O. The I is the two innermost terms. So now you're starting to distribute that negative F. So this negative F times R is a negative FR. And then I take this negative F times the negative F. That'll give me my L, which stands for the last ones from each parenthesis. So a negative F times a negative F will give me a positive F squared. So Leah, did you have this like this at this point? So y'all, can I go further? Okay, so you had, yeah, so one sign messes you up on these. But yeah, I got like terms there. So bring down your R squared, a negative 1FR and a negative 1FR give me a negative 2FR. And then at the end, I bring down my positive F squared. Now, Now, I'm going to show y'all one where stuff does cancel on it. This won't be on the homework, but I'm just giving y'all an extra bonus here, I guess you could say. What if I had something like x minus y times x plus y? Do y'all see how these are exactly the same other than one's being subtracted and one's being added? This kind of stuff is what we call conjugate pairs. So that could be x minus 5, x plus 5, x minus 3, x plus 3. Conjugate pairs look exactly the same other than one's being subtracted, one's being added. Watch what happens when you FOIL these. So let me see where y'all are. Oh, not when you're adding and subtracting. Only if you were multiplying, you would add those exponents, okay? But if the variables don't match, like the f times the r, they just get put together and they still got, technically, these still got exponents of 1 by those ones, okay? All right, y'all, watch what happens when we FOIL conjugate pairs. X times x is an x squared. X times a positive y is a positive x y. All right, let me distribute the middle now. Negative y times x is a negative x y. So I'm just keeping them in alphabetical order. And then that negative y times y gives me a negative y squared. So do y'all see what's happening to these like terms right here? You got a positive xy and a negative xy. These ones actually cancel out. So that if you FOIL conjugate pairs, you always end up with something like an x squared minus y squared. The middle terms will always cancel out on conjugate pairs, okay? And y'all, that's the only way that those oh yeah, it's always minus because you had a negative times a positive on that one, okay? Um, so y'all are asking, so say I didn't put them in order and I had an x squared plus my xy minus a yx minus y squared. So Levester, so the thing is, although these ain't in alphabetical order, they're the same thing. You got an xy here and a y times x here. So since they're technically the same variables, they're just not in order, these would still cancel out for you, okay? Um, it's just easier for me if I got them in alphabetical order, then it's really easy to see them easier. But yeah, you don't have to do the alphabetical order, okay? All right, y'all. So the last one, y'all, let's see what they gave me. Woo, they made a good one. X3 plus 7, and then a x3 minus 6. So they just wanted to jack the exponents up a little bit for you. So I'm going to FOIL the x3 times the x6. I mean, x3 times x3. So what'd y'all get on that? So x6, good job. And then I'm going to take the x3 times negative 6 so that you get a negative 6 x to the third. Now, Taylor, you got 2x6, but remember, those are ones in front of these, and you're multiplying 1 times 1. That's going to keep that as a 1 on it, okay? All right, also, x3 times negative 6, negative 6x3. Then I take the 7 times x3, I get a positive 7x to the third. And then finally, that 7 times that negative 6 is a negative 42. Would y'all go further? Yeah, we got these x thirds that look the same in the middle. So bring down your x6. Oh, look at that. Negative 6 plus 7 leaves me 1x to the third. And then at the end, I'm going to bring down my negative 42. And then y'all, no further can I go. So here's the thing. You can only change exponents when you multiply. So x third times an x third gave me an x6. Once you're done with multiplying and you're adding and subtracting, you better not change them letters, right? You cannot change the letters by adding and subtracting. Only up here when we multiply, okay? And then, yeah, that's our final answer. And we're done. All right, y'all. So 2-9's not too bad. 2-3, like I said, was doing a little domain and range stuff. Support for 2-4 was doing these 5 problems where you did little distributing with the negative in parentheses, multiplying, and a little bit of foiling down here, okay? So let me ask y'all, any questions?
No, sir.
All right, any of y'all need any help on anything? Oh, hang on, let me see what y'all, let me go back up. Someone had a question. So y'all got 100 divided by 4 times 2 plus 3. So here's the question. Is this like this? 100 divided by 4 times this? Or is it like this? Because technically, if it's sort of like that, then I would do the parentheses first. So I'd have 100 divided by 4 times 5, right? All right, what's 100 divided by 4? Oh, y'all are all missing that. You know that, right? So 100 divided by 4 is 25. And then you got a 5 over here. So now 25 times 5 is 125. Remember, PEMDAS. P means can it work inside parentheses? E means exponents. M and D, multiply or divide, but you got to go left to right. So you might have to divide first or you might multiply first, but you got to go left to right. So at this point, when I had division and multiplication, I went left to right and divided first and got to 25. And then A or S is add or subtract, and that goes left or right. So have y'all ever heard this? What does this, what did they tell y'all to remember this stuff? PEMDAS. Please excuse my dear Aunt Sally. Now here's my question. Where is she from? Where was Aunt Sally from? Oh, well, guess what? She from Little Rock, left to right. Y'all ain't never heard that. So that lets you know that these two and these two, same priority. They just go left to right, okay? All right, what else y'all got? I'm gonna quit my share so I mean my recording so I can get that sent out pretty quick.